Good morning, Algebra 2 Trig Honor students. So it's me, Mr. Chen, once again. So welcome back. And again, if you guys do like the previous video, so make sure that you click the subscription button right there, subscribe to the channel, and click the bell. And finally, we're getting to the reference angle and also with the unit circle. So unit circle, I think there's another video on my YouTube channel, so make sure that feel free to watch the other one too. It's about the way that I put up the special right triangle on the unit circle. So the one that I have for the video today, this one is just a little bit more in-depth for the analysis about applying the special right triangle within the unit circle. So the unit circle is a radius 1. Well, the reason why it's 1 because it's called a unit. Unit, that means always 1. So the radius is 1 unit, and its center is always right at the origins of the coordinate plane. So the points on the unit circles are related to the periodic functions. We'll get to the graph for the function in the new unit. And you can use the symbol theta for the measure of angles in standard positions. So here's the unit circle with the radius 1. Again, the center is right here at the origin. So which is what, 0, 0. So you may notice that the equation of a circle is x minus h quantity square plus y minus k quantity square equals r square. So this one, h comma k, 0, 0. So it's x squared plus y squared equals r squared. Okay. So let me just rewrite this. And now for the unit circle. So let's say that we do have a point on the unit circle. So this one is showing that's 30 degrees. But assuming that we don't know what that is. So this one is just saying that it's like x comma y. Okay. So let me just redraw the figure with the unit circle. So here's the radius, so that's 1. And the point here, x comma y. So this component here, then that'd be x, this one is y, and here's called theta. So if you guys are wondering about cosine of theta, so this one is considered x over 1. Adjacent over hypotenuse. And then sine of theta, it's y over 1. So try to simplify this. So that means x equals cosine of theta. And then y equals sine of theta. So that's why this one, the definition is showing that cosine and sine of the angle. So cosine on the unit circle is just the representation of the value of x. And then sine of the angle is just the representation of y. So making sure that you need to recognize this basic structure. So it's kind of like an identity for the coordinate. So cosine of that angle in the unit circle, it's always the value of x. And then sine of the angle on the unit circle, it's always the value for y. So this one is showing that the special triangles, the ratios. So instead of using that 1/2 root 3 over 2, 1, so this one giving you the ratios of sine. Sine of 30, it's 1/2. Sine of 60 is root 3 over 2. And sine of 90, that's 1. But instead of using all this ratio, I just want to put in that the regular ratios for the line segments of the special right triangle. So 30, 60, 90. Okay, so 30, 60, 90 degree triangle. And then the ratio here, it's always 1. Over here, the longest leg, so then that'll be 2. Down here on the bottom, it's root 3. So it's 1, root 3, and 2. And also this one shows that the ratio for sine of 45, sine of 45, sine of 90. So just cross those out first. And we're using the special ratios of this in other special right triangles. So this one would be considered an isosceles triangle. Yeah, this one, the side length should be exactly the same. Let me just resketch the diagram. So special right triangles, 45, 45, 90. So 45, 45, 90 degree. So this one is considered 1, 1, and root 2. So 1, 1, and root 2. Okay, so now let's find out those ratios within that 30, 60, 90 degree angle in the unit circle. So started off with the 30, 60, 90. So let's say that the base angle is 30. Here's 90. And this one is 60. Again, using the ratio as the one that I just identified. So it's 1, root 3, and 2. And also the formula that we know. So x, which is what? Cosine of the angle. and then y, which is sine of that angle. So the one that I put up here, this one is just the ratios for the line segments, 1, root 3, and 2. So for the table, so for the angle, let's say that it's 30 degree. So sine of 30 degree. So sine of 30, which is what? Opposite over hypotenuse. Or we can say that it's what? Y over R, which is what? 1/2. And then cosine of 30. So cosine of 30, which is considered x over R, then that'd be root 3 over 2. And then tangent of 30. So tangent is opposite over adjacent, so it's y over x. Again, you can always label this x, y for the ratios. And this one is just the radius, the ratio for the radius, which is what? 2. And then y over x. Then that'll be considered 1 over root 3. Try to rationalize it, then that'll be root 3 over 3. And then the rest of this is just the reciprocal ratios of sine. Cosecant of theta, the reciprocals of sine, which is what? 2. Secant of theta, reciprocals of cosine, then that'll be 2 over root 3, or 2 root 3 over 3. And then for cotangent, it's the reciprocals of tangent. So the reciprocals of tangent, which is root 3. And now what about for 60 degree? So here's another triangle, but this time it's 60 degrees, so it's all the way up here. So 90, here's 30. So 60, so the ratio for that opposite, so this one is root 3. Adjacent, it's 1. And then this one is 2. Again, I'm just using that, the special ratio of the special right triangle, 30, 60, 90 degree triangle. Okay, so using the formula, so sine of theta, y over r. So base angle this time is 60, so y over r, root 3 over 2. So root 3 over 2. And then cosine of 60, which is adjacent over the hypotenuse, or x over r, which is 1 over 2. As you may notice that 30 and 60, the ratio right here, they kind of like, the same. So cosine of 30 is the same as sine of what? 60. Okay. Well, cosine of 30 is the same as what? Sine of 60. And then cosine of sine of 30 is the same as cosine of 60. And then tangent. So for tangent is y over x. So the ratio for this one, so root 3 over 1, which is root 3. And then cosecant, it's the reciprocals of sine. Okay, so sine of that angle, which is 2 over root 3. And which is 2 root 3 over 3. And then secant of 60. So cosine of 60 is 1/2, reciprocals of this, which is what? 2. And then cotangent of 60, reciprocals of tangent of 60. So it's 1 over root 3, which is root 3 over 3. And now what about 45, 45, 90 degree triangles on a unit circle? So 45, 45, 90, so we do have a kind of like an angle bisector for the terminal sides. And then this one here all the way down. So 45, 45, 90. So the ratio for this one, it's considered 1, 1, and root 2. So 45 degree angle. So sine of 45, opposite over hypotenuse. So it's 1 over root 2, or root 2 over 2. What about cosine of 30? Adjacent over hypotenuse, x over r. It's also 1 over root 2, which is root 2 over 2. And then tangent of 45. So tangent, opposite over adjacent. So 1 over 1, which is 1. Cosecant of theta, cosecant of 45, which is the reciprocals of sine. So which is what? Root 2. And then secant of 45, reciprocals of cosine. It's also root 2. And then cotangent, reciprocals of tangent, it's also what? 1. So make sure that you guys refer back to another part of the video that I have regarding the unit circle. We actually will get into the detail of the unit circle regarding the quadrant number and also the way to find the reference angle and also the structure of the whole unit circle. So make sure that refer to the other, watch the other part of the video that I have on my YouTube channel regarding unit circle. Alright, so I'll see you guys next time. So you guys have a great one.